Okay, so welcome to the new topic. It is going to be circuits. So in the last lessons we looked at static electricity. This unit or the section of work will be looking at DC or direct current. So today's learning objectives are going to be three: to identify common circuit symbols which you're going to use throughout the course, identify electrical current as the flow of charge or electrons, explain how current behaves in series and parallel circuits. So these are the circuit symbols that you need to know. There's the cell, the battery, the LED or bulb, the resistor, the ammeter to measure current, the voltmeter to measure voltage, a switch which is closed, and a switch which is open, a LDR or light dependent resistor, a thermistor or a resistor which is dependent on temperature, and a variable resistor, and finally a fuse. So by the end of this unit you should be able to incorporate all of those into circuit diagrams. So what is electrical current? Well, electrical current is the flow of electrical charge, be it positive or negative, and charge we've now discovered from the 1850s comes from the electrons. So if we magnify up this aluminium can of Coke, you can see there is atoms of aluminium, and if we further magnify that, getting down into the atoms of the aluminium, you have a proton and neutron of the nucleus, and the electrons which are orbiting. And you can have free electrons. So unfortunately, the one complication with current is the idea of conventional current. So conventional current, as we discussed in the static electricity, goes from positive to negative. So electrons move in the opposite direction, okay, reinforce that, the opposite direction of conventional current. In conventional current, the charge carriers are positive, okay. So here we have this diagram here, so you have the direction of conventional current going from positive to negative, whereas in reality the electrons, which are the charge carriers, go in the opposite direction of our conventional current. Unfortunately, it's our convention. We've had it from the 1850s, so you just have to be aware of that. Okay, so what does this look like in an electrical circuit with electrons moving around? Well, electrons flow around the circuit. They start at the negative anode and will end up back at the positive cathode, where they undergo a chemical reaction to form more electrons. And as they gain energy from that cell through a chemical process, they then transfer their electrical energy from the electron to the lamp, where you see that in the form of light, and then go back to the cell and regenerate, and electrical charge is again formed. Okay, so the way we measure current is that we use something called an ammeter, and it's placed in something called a series circuit, which we're going to go over, kind of going over what we did last year. And they need to be measured. You need to measure the current flowing through them. Okay, it's very important they go through them. That's why they're in series. So we just attach it there, and you can measure the current. Okay, so series and parallel. So series is when the circuit is in one complete loop, whereas in parallel there are two or more branches, so the current or the electrons have options. So here we have a current starting off of 1 amp, goes through the circuitry and ends up through A1 as also being 1 amp, and A2 also being 1 amp. Okay, in this example here we have 4 amps to start off with, so this is our starting point, and divides into 2, so it's going to be 2 amps here, and ends up, after it's all gone through, being 4 amps at the end once they've joined up. Okay, this example here, we start off with 6 amps. We have 3 division points, so that's going to be 3 amps. 2 amps. I've got maths. 2 amps here, 2 amps here, 2 amps here, and they all combine up again to give 6 amps at the end. So the final example is slightly more complicated, where we have a total of 3 amps, so you've got to work out what's going to be. Okay, there's more resistance here, so it's not probably going to go that way. So less current's going to go there, so it'll be 1 amp, and it will be 2 amps there, a 1 to 2 ratio, easily divided, and then they combine it again to give 3 amps. So the overall rules are for series, the currents are all equal, and for parallel, the sum of the currents will equal the current total. Okay, and that's pretty much it for today's lesson.